In this movie, you learn to build a detailed baseball right down to the seams and stitches. In doing so, you'll use two max creation graphs you have learned about in other tutorials on this channel. These would be the MCG clone tool and the MCG conform mesh tool. If you haven't followed the tutorials that relate to these tools, you can certainly do so before moving on. However, you can still skip viewing those tutorials and simply load the tools as they are part of the zip archives you downloaded for this tutorial. For that, start 3ds Max and then from the scripting menu choose Install Max Creation Graph.mcg package. Browse to where you have stored the files you downloaded. There should be two of them. Select one to view its information and then click Install to install the tool on your system. Repeat for the other file. More information about installing and packaging graphs is showcased in another movie on this channel named MCG Packaging and Installing. The install procedure you just did added two new modifiers to your system, both starting with the prefix MCG. In a nutshell, the MCG clone modifier is a duplication tool where you specify a number of clones with options for position, rotation, and scale offsets. What makes this tool interesting is that the end result is viewed as a single object. You'll use it later to create the stitching on the baseball. The MCG conform mesh tool is a modifier that ensures one surface conforms to another with some relax and offset parameters built in. You will use both modifiers to good effect, along with some other 3ds Max workflows to create a detailed baseball. Start or reset 3ds Max. Make sure your system's units are set to inches and that your display units are set to generic. Create a box and make it 40 units on each side. Press F4 to view the scene in Edge Faces mode. You may be using this toggle key often in this tutorial, so remember it. In the Hierarchy panel, center the pivot point to the box. This is done by using the Effect Pivot Only and Center to Object buttons. Exit this mode and relocate the box to the center of the world at 0, 0, 0. In the Utilities panel, use the Reset Xform tool to reset the transformation matrix on the object. And finally, convert the box to an editable poly. Next, create a sphere with a 20-unit radius. Relocate it to 0, 0, 0 so that it fits inside the box. If you want, you can see it better by temporarily using the F3 wireframe toggle. Actually, you can hide the sphere for now using the Scene Explorer. You don't really need to see it. Select the box again and apply a Turbo Smooth modifier to it with an iterations value of 2, in essence spherifying the box. Although a baseball is spherical in nature, using a box and turning it into a sphere prevents the pinching that a traditional sphere has on its poles. Also, this helps with edge flow as you later define the path where you want to place the stitches. Go back down to the editable poly level, but make sure you enable the Show End Results toggle so that you can see what you are working on. Try something for size. Go into Edge mode and note the orange edges representing the base box. Select the following edges with the help of the Control key. In the Edit Edges rollout, note what happens when you adjust the crease value. The selected edges act like magnets to the geometry of the box by pulling in vertices. Exit Edge mode and go to the top of the stack. Add the MCG Conform Mesh modifier you installed previously. Use the surface input to select the sphere in the Scene Explorer. The sphere-fied box is now slightly bigger as it conforms to the size of the hidden sphere you built earlier. You can in fact further adjust it by editing the push amount value. Leave it at 0 for this tutorial. Now go back down to the editable poly edge mode and try the crease value again. Set the crease value to 1. This time there are two forces at work. The selected edges are still trying to pull in vertices, but the conform mesh modifier prevents the object from deforming too much. It remains a sphere because it's conforming to one, but the edge flow changes and now presents you with a perfect loop to add seams and stitches. Exit edge mode and go back to the top of the stack. Add an edit poly modifier and go into edge mode again. Select one of the edges on the seam where you will eventually add stitches and click the loop button. The loop is interrupted when it reaches a 3-point vertex. Use Ctrl-click to add the next edge in line and use the loop tool again. Even easier, you can hold Ctrl and double-click the next edge to select the next loop. Keep going until the whole loop is selected. Next, you'll use the chamfer tool to create the seam. Here's a little tip for you. Typically, you use the Edit Poly Model mode to model, if you are not planning to animate the deformations. So here, you can certainly use chamfer to turn the loop into a double loop. However, you have no means to edit the chamfer size after creating it. The Settings button is grayed out because changes done in this mode are automatically committed. You would need to undo the command and rerun it to get different results. If you use the same technique in Animate mode, though, you will find that you can access the settings at any time to refine the changes, as long as you haven't manually committed those changes. This will enable you to revisit the parameters at any time later to fine-tune the results. Exit Edge mode and rename the modifier Edit Seam. Next, add another Edit Poly modifier on top and access Edge mode yet again. This time, select the ring of edges that chamfer created earlier. This can be done by selecting one edge and then using the ring button, or by selecting one edge and then shift selecting the one next to it. Click the Connect button to connect all these edges together with a new edge loop. Use the Scale tool to scale the loop down to create a crease. Exit Edge mode when done, and rename the modifier Edit Crease. Add another Turbo Smooth on top of the stack. Set it to Isoline Display to make the ball easier to read. At this point, you can go back for further refinements. You can readjust the seam, or the scaling of the crease loop. This takes care of the ball itself, but you still need to extract information to create the stitches. Temporarily disable the Turbo Smooth modifier at the top of the stack so you can see clearer, and go to the Edit Crease Edge mode level. If you followed along, the crease loop should still be selected. Click the Settings icon next to Create Shape. Make sure the type is set to Smooth to create a curve, and name the new shape Stitch Loop, and then click OK. Exit Edge mode and enable Turbo Smooth once again. Next, you tackle the stitches. Stitches on a baseball are usually set in a V pattern. You need to create one stitch and then duplicate it to follow the loop you extracted. Temporarily hide the baseball. You should be able to see the stitch loop a little easier. In the top view, and strictly for reference purposes, Draw a rectangle as big as you feel a single stitch may be, about 1.5 by 2 units. Zoom in on it, and using the line tool, draw the first line representing a stitch. Disable Start New Shape, and then create the second line of the stitch. Rename the object Stitches, and then delete the reference rectangle when done. Select the stitch shape again, and make it visible in the viewport and at render time. A thickness value of 0.3 should be fine for now. Go into vertex mode and convert the vertices to Bezier mode. And then adjust the handles to curve the stitch somewhat. If you need to, change the wire color to see the stitch better. When you're adjusting handles, use the F8 toggle to switch axis coordinates based on the view you are working in. Move the stitch to the side and adjust its pivot point. Center it, or move it manually to relocate it where you feel it should be. Next, unhide the box that you turned into a baseball. In fact, rename it accordingly and call it baseball. If you need to, change this wire color as well. Select the stitch and apply an MCG clone modifier to it. This modifier was created using the Max Creation Graph tool, and there is a step-by-step tutorial on that subject on this very channel. It enables you to define a number of duplicates with offset options for position, rotation, and scale. Here, you only need to define a number of clones and a Y offset distance. At this point, you are not 100% sure of either value, so use about 10 duplicates with a Y offset value of about 3. You'll change these in a moment. What is more significant is that the end result of this modifier ensures all the duplicates and the original are regarded as one object. This means you can add a Path Deform WSM modifier to the top of the stack and pick the stitch loop as a path to follow. You also want to use the Move to Path option and specify the same deformation axis that you specified as a clone direction offset, in this case Y. At this point, the stitches could be pointing the wrong way. You can edit the Path Deform rotation value to get them right. In this video, a value of about 140 degrees seems about just right. Also, the stitches seem to be digging a bit too deep. To adjust that, go into Editable Spline mode. Disable Show End Results temporarily on the modifier stack. In the front view, select the two splines that make the stitch. Note that you can move them up or down without affecting the pivot point. Since the pivot point acts as an anchor when using Path Deform, moving the splines up or down induces a vertical offset. Enable Show End Results yet again, and move the selected splines up or down to see the results. Adjust the splines until you get a good result in the viewport. Finally, to add more stitches, it's a question of going back to the MCG clone tool and adjusting the values. Again, in this particular example, I will set the clone number to 95 and the Y offset to 1.72. If you need to, you can also go back to the spline level and adjust the thickness of the stitch. That's it. You can take it from here and apply your own materials and lighting to the scene. If you prefer, you can take a look at the finished version of this project found in the zip archive you downloaded for this tutorial.